All right, guys, today we're going to be working on proportional relationships using our using a word problem. We're going to talk about Jalen, and Jalen just finished a 7-mile run. Okay, how long do you think it took him? Go ahead and tell me. How long do you think it took him? Type your response in. You might be thinking, wait, Miss Dawes, that's really hard. How am I supposed to know how long it took Jalen to run 7 miles? So click to the next slide. You're right. I did not give you enough information to tell you how long it's going to take Jalen to run 7 miles, did I? So what information do you think you need in order to make a more accurate prediction of how long he ran? Type it in. Awesome. So you're thinking, oh, you need to know how long it takes him on average. How long does he normally take to run 7 miles? How long does it normally take him to run 1 mile might be an option. How long does the average person take to run a mile? Those are all great options. Click to the next slide and we're going to get some more information. All right, so we're going to say that this blue point here represents how long it took Jalen to run 4 miles. Okay, it's right here. So that's 33 minutes for 4 miles. So now drag the red dot to help create a line or a model for this data. Go ahead and go. Where do you think would be a good spot for this dot to go on 1 mile to help make a line, straight line from 0 for this data? Go ahead and start. So here's how I'm going to do it. So if I know I'm making a straight line here, I'm going to draw that line across. And yes, it is going to be difficult to do it 100% on here. So there we go. So if I drag my red dot, it put my red dot somewhere. Let me get that line a little more clear for you guys. Sorry. There we go. That's a little bit better. So I put that red dot somewhere around here, right? Which, if we look at our scale here, it says this is 40 minutes, so this must be 10 minutes here, 20 minutes, 30 minutes. So it looks like he ran a little bit under 10 minutes is 1 mile time, okay? So go ahead and click now and go to the next slide. Based on the prediction that we just made, so I'm going to redraw that prediction. Okay, how long do you think it takes him to run 7 miles? So if we said he's just under 10 minutes for 1 mile, how long do you think he's going to take to run the 7 miles? So that's 5, 6, and here's 7 here. So it's going to be somewhere around here. How long do you think it's going to take him? Go ahead and start. So what I'm going to do to figure that out is I'm going to go to 7 here and I'm going to just trace my line up and I'm going to see that it's somewhere around 50. So it's going to take him around 50 minutes-ish. Okay, so approximately 50 minutes to run 7 miles. Okay, that's what I think. That's my prediction. So let's go to the next one. So what does the equation 8.25 mean in terms of distance? So if we said what the equation of our model is y equals 8.25x, well, we know that k here, that 8.25 is our rate of change or a constant of proportionality, right? Because we know this equation y equals kx. And we know that k represents constant of proportionality or rate of change. So I'm going to put COP or ROC here. Okay, so we know that k represents either the constant of proportionality or rate of change. So that means he must be running for his rate of change. That must mean that if it's y over x, they did 33 divided by 4 to get 8.25. Which means that 8.25 is now the time it takes for him to run 1 mile. Because time is on top, because time is our y. And the distance is on bottom because distances are x. So that means 8.25 is going to be his time it takes to run 1 mile. Go ahead and type that in here. So if we were to put that on our graph, we would then have to go and put a point somewhere around here, just below 10. Hey, isn't that close to where we had already predicted our point to be? Yeah, it is. And then we'd have to draw it out. And we could do it even easier by saying 8.25. Well, 8.25 double is 16.5, so it's going to be somewhere around here. 8.25 times 3 is going to be 24.75, so that's like here. And look, it's going to be even easier for me to draw my line now because now I've got more points to put on there. So it took him 8.25 minutes to run 1 mile. All right, let's go ahead and go to our next slide. Okay, so the equation of our model is 8.25. Where in the graph does the value 8.25 appear? Well, let's see. If we were to put that on our graph again, we said 8.25 and 1, then 16.5 here, and then 24.75. So where does the 8.25 appear? What do you guys think? Where does it appear? Go ahead and type it in. All right, so there's actually 2 places where it appears. First is right here. Okay, we know that at 1 mile he ran 8.25, so that's our first point. But it also appears from 8.25 to 16.5, and from 16.5 to 24.75, and from 24.75 to 33. All of these are 8.25 because that's how much we're changing between each mile. So it appears not only just where it equals 1, but also in between miles, in between points. All right, let's click on our next one. The y-intercept is 0. So y-intercept, if you guys don't remember, this should be reviewed, but if you don't remember, that's okay. The y-intercept is where it crosses this y-axis here, this up-down axis. And they said it's 0, meaning that the graph starts right here at 0, 0. Do you think that's correct? Explain why or why not. Take a few moments to do that now. Awesome. So many of you guys said that, yep, that's correct, and you're right. Because if 0 minutes have passed, has he started running yet? No, so it should be at 0, 0, and it should start at 0, 0. All right, let's move on to our next one. All right, so now we've got a short video to play. I want you to pause and watch the video on your own. Take a few moments to do that. All right, after you've watched the video, how many minutes does it say it took him in order to run 7 miles? 55 minutes, right? Is that pretty close to what our initial guess was? Yeah, I said somewhere around 50 minutes. So I'm a little bit off, but I'm not horribly off, right? So we could look at the graph and we could graph it and predict that even better by saying 8.25, then up 8.25 is 16.5, then up 8.25 is 24.75, then 33, then up 8 from 33, going up 8.25, well 33 plus 8 is 41.25, so going just above 41 here. And then 8.25 would be like 40, almost like 50, pretty close, right? And then we've got 57 here. So if we drew our line based off the prediction of our up 8.25s each time, you can see that 7 here, if I trace up at 7, we could have seen that it was around 58 or 57.55 from our graph. We could have predicted that. All right, let's move on to the next slide. Okay, what advice would you give a classmate making an accurate prediction for this situation? Okay, so if we had to predict how many miles that he's going to take to run 14, or how much minutes it's going to take him to run 14 miles, what would you tell a classmate in order to make an appropriate prediction? Pause this video and write that out now. All right, so some of you might have said, like, if we're doing 14 miles, you're going to do 14 times 8.25. Some of you might have said graph it out and follow the graph. Some of you might have said, oh, since 14 is double what 7 is, you're just going to double the amount it took him there. Any of those would have worked. Good job. Let's go to the next slide. All right. Jalen's graph is shown here. Now we have Maria, though. Maria she doesn't run quite as fast as Jalen, okay? She runs 8 miles in 57.5 minutes. How is her graph going to compare to Jalen's? Okay, is it going to be above Jalen's? Is it going to be under? Is it going to be a steep? You tell me. Go ahead and pause and figure it out. All right, so there's a couple of things I'm going to look at. So we've got Jalen's equation, which is 8.3x, okay? But we don't know what Maria's equation is. So we're going to find that out. And we're going to do our k equals y divided by x to help figure out her equation. So I'm going to do 57.55 divided by 8 to figure out how long did it take her to run a single mile. Okay? So I'm going to divide it out, and I'm going to say 57.55, and 8 is going to go out here. 8 can't go into 5, but 8 can go into 57. That's going to go 7 times. 8 times 7 is 56. So I was actually wrong. We can see here already. Looks like Maria actually runs faster than Jalen because she's at 7 minutes versus 8 minutes per mile. Okay? So I'm going to bring the 1 down, bring the 5 down here. 8 goes into 15 one time, minus 8. So 15 minus 8 is 7. Then bring the 5 down. Okay, 8 goes into 75. 9 times. 8 times 9 is 72. I'm going to go ahead and leave us there, though. With hers, it takes her about 17.19 seconds. So that would make her equation y equals 7.19. So she's actually going to go have a steeper line than Jalen. Her line is going to be steeper because she's going to go up faster. If I were to put this on the graph, so it's going to go, or sorry, she's going to have a less steep line than Jalen because our time is here. It's going to take her less time to get places. So if I'm to put it on the graph, well, we know at 1, she's at 7.19, which is a little bit below. At 2, she's only at 14-ish, which is still below. At 3, she's at 21, which is like right here. At 4, she's at like 27, 28-ish. At 5, she's going to be around 35-ish. So you can see over time there starts to be a pretty big gap between Jalen and Maria and their lines. And her line is less steep. All right, so the table shows the times from Jalen's run. I want you to calculate all the missing values in the table. All right, go ahead and start. Pause the video. All right, so if I'm calculating the values, what I would do in this case, because I don't know. So I know my equation last time was 8.3. Let's see if that's still the case by finding my k. By dividing 16.8 divided by 2. I'm doing that because k equals yx. So 2 goes into 16 8 times, but 2 goes into 8.4 times. So this time he's running 8.4. So now I need to figure out what that means. It took him to run 24. So if our equation is y equals 8.4x, to find out how long it took him to run 24, I've got to plug it in here. So I'm going to have 24 equals 8.4x. Now I've got to solve for x, center my equation's equal sign, and divide by 8.4. So now I'm going to do 24 divided by 8.4. Move that over 1, move that over 1. Okay, 84, how many times do I think it goes into 240? Well, 84 times 2 is around 160. 84 times 3 is going to be around over 240, so I'm going to guess 2. Okay, 2 times 4 is 16, carry the 1. 2 times 8 is 16, plus 1 is 17. Okay, so 0 minus 6 I can't do, so I'm going to make that a 3. 10 minus 6 is 4. I can't do 3 minus 7, so I'm going to make that a 13. 13 minus 7 is going to give me 6. 1 minus 1 is 0. Then I'm going to bring my 0 down. So now I have 640. So I'm going to go with 7. 7 times 4 is going to be 28. Carry the 2. 7 times 8 is 56. Plus 2 is 58. So now I've got to subtract. So that's going to give me 10. 3. 10 minus 2 is 2. 3. Now I've got to borrow. Make that a 5. 13 minus 8 is 5. So now it's 520. So that's going to be 6. And I'm going to leave it there with 2.76. So 2.76 is that spot there. So now I need to go and I need to find out what the value is here. So how long did it take me to take Jalen to run 3 miles? Okay. So now the miles part is the x, so I'm going to plug in 3 for x. And I'm going to do 8.4 times 3 to find out my y. Okay, 3 times 4 is 12, carry the 1. 3 times 8 is going to be 24, plus 1 is 25. Put 1 decimal place in it. So it's 25.2 is going to go here. So now I need to figure out 36. So again, to do that, I'm going to do y equals 8.4x. It's saying how many miles did he run in 36 minutes? Well, 36 is the y value, so I'm going to put 36 here. Equals 8.4x. Center my equation's equal sign. I got to divide by 8.4, so I'm doing 36 divided by 8.4 to figure out my x. So I'm going to go ahead and long divide that. So it's 36, 8.4. Got to move my decimal one place. Okay, 84 is going to go into 360, probably close to 4 times. So 4 times 4 is going to give me 16, carry the 1. 4 times 8 is going to give me 32, plus 1 is 33. So now I've got to subtract it. I'm going to have to borrow. 10 minus 6 is 4. 5 minus 3 is 2. 3 minus 3 is 0. So now I'm going to bring the 0 down, put my decimal there. Okay, 84 is going to go into 24 around 2 times. 2 times 4 is 8. 2 times 8 is 16. Borrow from there, make that a 3. 10 minus 8 is 2. Borrow from there. 13 minus 6 is going to give me 7. So now I have 720. Bring the 0 down. Okay, it's going to go into 720 about 7 times, and I'm going to go ahead and just leave it there. So it's 4.27. So now to find my last one, I have to repeat like what I did over here. I've got to plug in for distance, which is x. So I'm going to do y equals 8.4 times 6. 6 times 4 is 24. Carry the 2. 6 times 8 is going to be 48. Plus 2 is 50. Then put my decimal point in there. So it's 50.4. Now I have my chart all complete. And we have done all of our analysis for today. We are completely done with analyzing our proportional relationship today. We've used a graph to help us predict. We've used equations to help us fill out a table. We've made predictions about other people, about other graphs compared to ours. So now you guys are good to work on your proportional relationships and percentage focus area. Have a great day, guys.